going to go over geometric probability. So first we need to know what that means. Geometric probability is probability using lengths, areas, volumes, or percentages. And it's always part over whole, every single time. What's the part that you're trying to get over the whole thing, every single time? For this whole probability unit, we will be writing our answers as both fractions, decimals, and percentages, because your answer could be put in either of those ways. On your test, well, I guess it's a quiz. Of course, it'll be multiple choice, but you need to know how to find all three ways so that you know which one is the correct answer. So our first problem is a linear problem. So it's going to be based on sort of a number line, but not completely. So it says Morgan, Phil, Callie, and Tyrese are sitting on the side of a pool in that order. So in other words, we have Morgan, we have Phil, we have Callie, and we have Tyrese. Morgan is 2 feet from Phil. So in other words, they're all sitting next to each other, right? So this distance is 2 feet. Phil is 4 feet from Callie, and Callie is 3 feet from Tyrese. Oscar wants to join them. What is the probability that Oscar sits between Phil and Tyrese? So between these two. All right, so we always do part over whole. So first of all, between those two is my part, which is 4 plus 3, which is 7. So it's always part over whole. And my part is 7. And then my whole is how far apart are all of them. So it's, oops, I did not mean to undo that 7. There we go. So it's basically 7 plus 2, which is 9. So this one would be 7 over 9. My answer would be 7 over 9 because that's my fraction. It can't be reduced. 7 over 9 is reduced as far as it can go. My decimal would be 0.7777, and we typically go 4, so this would actually be 8 because it keeps going 7s, 7, 7, 7, 7, 7 forever. So this is my decimal, and then my percent would, of course, be moving that decimal over 2 places, so 77.78%. Now, this is an area problem. So it's the area of hitting the bullseye. So our part, still part over whole, but we're going to be using the area formula. So first, our part is the bullseye. So this area, which our diameter is 2, meaning our radius is 1. So our part is the area of that circle. So pi r squared, so pi 1 squared. So that's my part over my whole. So in other words, the area of my entire circle. So if this is 2 and each of these others are 1, that means that this radius is 1, then 2, and 3. So my whole one has a radius of 3. So pi 3 squared. My pi on top and bottom will cancel. 1 squared is 1. 3 squared is 9. And there's my fraction. It's 1/9. It can't be reduced any more than that. My decimal will be 0.1111. It'll keep going 1 forever and ever, but we do 4 decimal places. And then whenever I turn this to a percent, this moves over twice, so 11.11%. Oops. There we go. So this is my answer. And then lastly, this is using degrees. It could also use percentages, but this one specifically is using degrees. What is the probability of hitting neither pink nor blue? So you want to hit everything except for pink or blue. So my part is everything except for pink and blue. So it's all of this. Okay. These are all degrees. So this one's 70. This one's 50. This one is not a degree. Oh, yes, it is. It's 90. I'm silly. So my part, it's still part over whole always. So 70 plus 50 plus 90 is my part. And then my whole would be the entire circle, so 360, because they should all equal 360. So 70 plus 50 plus, that should say 90, not 9, sorry, would be 210 over 360. But we need to reduce that because it will reduce. So 210 divided by 360 will reduce to 7/12. 7/12. So, and then if you do 7/12 as a decimal, you get 0.58 and then 333333333. Then my percentage, I move this over twice, so it's 58.33%. And we're done with those notes.